Welcome everyone to session number 2 of the Electric Education Center vlog. This week's subject is GFCI. GFCI stands for Ground Fault Circuit Interrupter. It's a device that was designed to protect humans from electric shock and electrocution. It was invented in 1961 by a fellow named Charles Dalziel, and it was brought to market around 1968. In 1971, GFCI protection was required outdoors at dwelling units like your house. In 1975, bathrooms was added to the list. In 1978, garage outlets that were accessible were added to the list. 1987, any receptacle outlet within 6 feet of a kitchen sink was added. 1990, added crawl spaces. 1993, wet bars. 1996, every kitchen outlet that serves a countertop. Notice I said outlet, not receptacle. 1999, electrically heated floors, etc., etc., etc. Now, the current rules are listed in your National Electrical Code book under section 210.8. So get your highlighters ready or get ready to take notes and take a look at that section 210.8. So why was the GFI brought to market? Well, people are exposed to electric injury anytime they come in contact with live electrical parts like wires or terminals. The type of path for electricity where you would be injured or hurt or killed could be hand to hand or hand to foot. Or, for example, if you're working at above a drop ceiling, like what's above my head here, and you should happen to touch a live wire, a live terminal up there, and your ear touches the metal grid, you would get a nice shock right through your skull. And that hurts. And this has actually happened. A short note about safety is this. As an electrician, as an apprentice, you should get used to always wearing gloves, even you students. Anytime you're working near energized parts, and this will prevent you from coming in accidental contact with these energized parts. Yeah, Rich, but I don't like wearing gloves. Oh, really? Well, for you, just Google electric burns to hands on the internet, have a look at it, and then see if you want to come back to me with a different statement, okay? Bottom line is this: hunt around for the most comfortable electrician gloves you can find. The ones that fit nice and they're easy to work with, buy them and wear them. That's the bottom line for safety working with energized terminals. Get in the habit of always checking these terminals, conductors, and equipment, even things like metallic light poles. Test them with a proximity tester. Okay, I have 2 models here. This one here is, there's the cigar-shaped size proximity testers, they call them. They have a tab on here that would stick into a receptacle. And when this particular device comes in contact with electric power, it would tell you that there is voltage present. Okay, this one I like because it comes with a nice LED that lights up the work area that you're testing. Okay, Milwaukee, this is a Milwaukee model, $18. So for $18, you could buy yourself your own personal lifesaver. Not a bad price. This one here, okay, this model here is a Greenlee special. It's a new device that's made for you electricians and electrical inspectors to test the tamper-resistant receptacles. Because as you know, a tamper-resistant receptacle, which I'm going to be covering in a upcoming issue of this vlog, the tamper-resistant receptacles, you need to put a prong in each slot for anything to enter. Okay, so this here has a hot and a neutral. If you put it in backwards, okay, it will give you a signal saying that that the polarities are reversed on the receptacle itself. So there's two types of proximity testers, and never trust a proximity tester. The only time I trust it is when it tells me something's hot. When it tells me something's hot, I believe it. When it tells me something's not hot, I don't believe it. So what you have to do is, with these proximity testers, both of this one and the Milwaukee, is test it on a known live circuit. Okay, so you go over in the receptacle here, you test it there, you get a signal, then you go above the ceiling, test it on that piece of equipment, you get no signal, then you come back to the original receptacle, test it again to make sure it's still working. And that way there, you've tested not only the circuit you're working on up in the ceiling, but you've also proven that your proximity tester works. Okay, so that is and it's all in the directions. When you buy that proximity tester, it's all in the directions on how to use them. One word to the wise is these proximity testers, they do not read through conduit. They do not read through MC, metal clad cable. Okay, they will not read through those things, and BX, things like that. No. All right, so you always have to read the directions. All right, so that's a little bit on the proximity testers. And when you want to test a GFCI receptacle or a circuit breaker, all right, I have a GFCI receptacle here. It's a GFI tamper resistant receptacle. It's got the test and the reset buttons on it. It also has some signal lights here for you. This new type here, this is Eaton. And on the Eaton receptacles, they have a signal that will tell you to replace the unit. It's hard to see here in the writing, but it'll tell you that if the light is blinking on there, to replace the unit. Because these receptacles, they are self-testing every 5 seconds or 10 seconds. They test their own circuitry, okay? But even with that, you still have to do the monthly testing, okay? The manufacturer still tells you that you have to test these things monthly, whether it's the receptacle or the breaker type. This is a Siemens circuit breaker here. It's got the white test button on it. And when this is on, you would hit the test button here and it would trip. And that's the way that the manufacturer recommends that you test them. Or you could just use what I use when I go out and I'm doing electrical inspections is the 3-prong tester. This is a Klein tester available at any supply house, same as the other manufacturers there I just showed you. And this style, make sure you get the style with the GFCI test button on it. Okay, they do make these without the GFI test button, but why bother? Go right to the 3-prong GFI testing style. Okay, so that's what I use. So you could use them when you're doing your work as you go to a customer's house. As anytime you get near a customer's building, residential or commercial, it doesn't matter. Okay, it does not matter. Yeah, check whatever you want. Okay, stick these in and check the polarity on any receptacle you want. If it's a GFI circuit, you would certainly have to be careful you don't take out circuits you're not supposed to. Okay, but you know, I'm just a very curious type inspector, and as I'm going different places, I will test with this tester. You know, I once did an electrical inspection, and it was at a hospital, and I went in to do the inspection, and the foreman got a little tiffy there because I was going to test all the receptacles. He said, "Come on, Rich, you know all the work is good." I said, "Really?" So I'm standing not 2 feet away from a fiery red emergency GFCI receptacle. And I plugged my tester in, and what did it tell me? Reverse polarity. So I looked at the foreman, and I said, you know, check them all, dude, and then call me, and I'll come back another day to do the inspection. So don't guess at any of your work. Always test it with a tester to be sure, because that's what the inspector is going to do. All right, so monthly test is due for the is required for the breakers and for the receptacles. They also I'll be doing a special session on receptacle talk alone, and I will be coming up with the talk about these things have to be readily accessible, and I will go through and explain that underneath a future session when we talk about just receptacles. That's all I'm going to talk about. So how do these things work? Well, this GFCI is designed to trip. Okay, this circuit will trip on this receptacle when there's an imbalance of 5 milliamps plus or minus 1. And that's why they'll say in the directions it's designed to trip between 4 and 6 milliamps. A milliamp is 0.001. At 5 milliamps is 0.005 amps. Okay, 0.005 amps. That's an amount that the body should be able to handle without injury. You get 1 amp going hand to hand for a couple minutes or a minute, I mean, you're pretty much guaranteed to be dead. Okay, so these things will trip at 0.005. Okay, well, they don't want to wait until there's 1 amp going through you. Okay, so if you were to touch an energized terminal somewhere in the kitchen with one hand and nothing happens because you're not grounded, but then you touch the metallic water faucet with the other hand, well, you've just completed the circuit, okay? And the current's going to flow through your body, and depending on how much and for how long, you could be dead. Keep in mind also that these things will measure an imbalance. So if I was to stick a knife in the neutral slot and in the hot slot at the same time and get 1 amp going through my body, will this GFCI device trip? And the answer is no. And I could be dead off of a GFCI protected circuit. If there's 5 amps coming from the circuit breaker panel to this receptacle, and 5 amps is going in one hand, and 5 amps is coming out the other hand and going back on the neutral back to the panel, the GFCI is going to sit there and say, well, another day at the office, 5 amps in and 5 amps out. Meanwhile, I'm dead. Okay, so these are designed for ground fault, okay? Somewhere the electricity is going where it should normally go. All right, that is a ground fault, and that's as soon as there's an imbalance, 0.005, it will trip. So, a little bit about being careful on the GFCIs. So, let's say the breaker knows that there's 8 amps going out to the toaster on the kitchen counter, and not all of it is returning to the breaker. Okay, as soon as there's that imbalance of 0.005, that breaker will sense the imbalance, trip immediately in less than 1/10 of a second. That's pretty fast, and prevent shocks and possibly save a life. So, which dwelling unit receptacles need GFCI protection? Well, the 2020 NEC has added to the list the 250 volt receptacles, which means that once the 2020 NEC is adopted in your area, some of these receptacles will need GFI protection also, even though they're 220 volts. This is the first time it's in the 2020 NEC. Pay attention to the words that are used in the NEC, because sometimes the NEC refers to receptacles and sometimes it refers to outlets. And plenty of people use the terms interchangeably and wrong. Now, you know what a receptacle is. Okay, this is a receptacle. But what is an outlet? The definition in Article 100 of the National Electrical Code in the NEC says, an outlet is a point on the system where electricity is taken to supply utilization equipment. That's the definition. So some examples of outlets are, for lights, for example, a lighting outlet. Smoke alarm, when you put a smoke alarm in the ceiling, That is an outlet. It's a point on the system where we're taking electricity and using it. Direct wired appliances, for example, that would be a outlet, not necessarily a receptacle. So keep in mind, all receptacles are outlets, but not all outlets are receptacles. Also, before you get lost or confused, when the code mentions 250 volts, just remember that 250 is a nominal value. So over the years, we hear on the job 220, 221, whatever it takes from the movie. We hear 230 volts, 240 volts, and now we hear 250 volts. They are all the same thing, and they're interchangeable unless the manufacturer's nameplate assigns a certain value. But when you hear somebody say 230 or 240, don't worry about it. It's all the same voltage. All you got to know is it's not 120. And speaking of 120, the same thing goes for 120. In the past, we've used 115, we've used 117, we've used 120, and now the National Electrical Code uses the 125 volt. They're all the same thing. It's just a nominal value. So the new voltage and amperage values in the National Electrical Code book. There's a big change in the 2020 NEC in the expansion of the GFI requirements in both the voltage and amperage levels. Once the 2020 is adopted in your area, a house dwelling unit like yours is going to require GFI protected receptacles for all 125 through 250 volt located in the usual places that GFI protection is required already. This will mean, for example, a 30 amp dryer receptacle in the basement. All receptacles in the basement right now, 125 volt, 15 and 20 amp, have to be GFI protected, every one of them. So now if you have a 30 amp dryer receptacle in that same basement, that will have to be GFCI protected. Same thing with the 50 amp receptacle for the electric range. If it's a 240 volt receptacle within 6 feet of the kitchen sink, it's going to require GFCI protection. And both of these instances, it's going to have to be provided by a 2-pole GFCI circuit breaker, because they don't make 50 amp GFI receptacles or 30 amp GFI receptacles. And I don't think anybody's planning on it either. So speaking of the NEC and how important it is to know what issue you're on, go to www.nema.org or go to nfpa.org to see the most current list of what issue is being enforced by what state. Right now, for example, the only state that's still on the 2008 NEC is Indiana. Okay, and there's some parts of that 2008 NEC that they chose not to enforce. The following states, I'll read them off to you. There's only 7 of them. The following states have already adopted the 2020 NEC. Our friends in Colorado, Georgia, Minnesota, South Dakota, Texas, Washington, and the state of Wyoming. Now, your assignment for today, I don't care if you're an inspector, a student, an electrician, a journeyman, an engineer, your assignment for today is to look up and find out what issue of the NEC your city or state is currently enforcing. You know, if you're an engineer in the Philadelphia area, well, the whole state of Pennsylvania is on the 2014 NEC, except Philadelphia commercial work is on the 2017 NEC. And then your close states of Maryland and Delaware are on the 2014 NEC. The state of New Jersey, also in this area, is already on the 2017 NEC. So you have to know what particular issue is being enforced in your area. The residential locations listed in the section 210.8a. What are they required in your house? Well, the bathrooms, the attached and detached garages, all receptacles. Ceiling receptacles included, yes. There is one state that does not include it, but it's a little crazy. All outdoor receptacles, yes. Crawl spaces at or below the grade level, doesn't matter, are included. Basements, all receptacles in the basement now are required to be GFI protected. Yeah, but Rich, what if I have a single receptacle, not a duplex receptacle? Dude, that still has to be GFI protected. What if it's the receptacle the washing machine plugs into? Yeah, it's got to be GFCI protected. Yeah, but what if it's a sump pump? If it's a sump pump receptacle, it's got to be GFCI protected. There are no exceptions. There are two coming up. I'll tell you later on coming up in this program here. But for the most part, all receptacles in the basement have to be GFCI protected. And I wanted to put a code change proposal in, and somebody beat me to it because I said if a basement requires GFCI protection when it's new, okay, and then somebody finishes off later on and makes it a den or a playroom or something like that, all of a sudden it doesn't need GFCI protection. Well, it needed it in the first place because it's a damp location or a wet location. So just because you're going to finish it off with some sheetrock and some paneling and some indoor-outdoor carpet on the floor, it doesn't change the fact that it's still a basement. So later on, even if you finish off a basement, the GFCI protection has to stay. You're going to have to add arc fault protection, and arc fault protection will be covered in an upcoming session. So basement, yes. Sump pump, yeah, but Rich, my customer doesn't want to put the sump pump on a GFCI receptacle. You know, they don't want it to go out in the storm. Well, that's not my issue. That's your issue. And sell that customer a battery backup for their sump pump. Okay, let them solve the problem. Don't let them make their problem your problem. You come up with a solution, battery backup, and let them make the decision. Sinks throughout the whole house. If there's a receptacle within 6 feet of the top inside edge of the sink bowl, must be GFI protected. Bathtubs or shower stalls. If you have a receptacle within 6 feet of the outside edge of a bathtub or a shower stall, it will be GFCI protected. Laundry areas. Note that it's not a laundry room. Okay, they can't call it a laundry room because sometimes it's in a closet, sometimes it's in a room, but sometimes it's in a basement. So the code calls it laundry areas. They need GFCI protection. Special cases, there are some exceptions, snow melting or de-icing equipment. Okay, they're allowed to go on a higher protection level. Refrigerator in the kitchen that's on an individual branch circuit, you know, what you electricians would call a dedicated circuit, though it's not. That term is not in the National Electrical Code. The term in the National Electrical Code is individual branch circuit. Look that up in Article 100. So say you have an individual branch circuit for a refrigerator, and the refrigerator is further than 6 feet from the kitchen sink. You see, that does not have to be GFCI protected. You cannot bury that GFCI receptacle behind the refrigerator because guess what? It's not readily accessible. That information is also coming up in a future session. So know your rules. Fire alarm system. This is like a fire alarm panel that's in somebody's basement. Cannot go on GFCI protection. And the same thing for a burglar alarm system. When somebody installs a burglar panel in their basement, okay, that is a burglar alarm system, and that should not be on GFCI protection also. All right, I promised you I would hit the middle 8 minutes, and I'm at that point, and thankfully there was not a lot of questions because I'm running short on time already. There were no questions per se from last week's vlog, but there were statements about the concept of the vlog. I got statements that said, I like the idea. Another one says, good luck. Another one says, it's long overdue, Rich. Looking forward to the series. The next one said, you're looking good. I missed the in-person meetings. Me too. Great presentation. Very smart and outstanding job of explaining the NEC. Thank you, Izzy. Congrats on the expansion of your platform. And the last one I have here, Rich, you've helped me for years now, and I would like to say thank you and looking forward to a great future. So now go ahead and send in the questions regarding this week's subject of GFCI protection. I know the one question is going to come up and you're going to say, hey, can I put a GFCI breaker on a circuit and also have a GFCI receptacle on that same circuit? Yeah, there's no problem with that. Okay, they're in series. One doesn't bother the other. There's no problem with that. So installation of these GFCI receptacles, in the early days and in the first generation of GFCI receptacles, and there's millions of them out there still, millions of them. It was possible to miswire a receptacle and the GFCI would still energize. You could swap line and load, you could swap hot and neutral, and it would still energize. The present generation of GFI receptacles will not even energize if you miswire them. So you get a homeowner puts in a brand new GFI and they call you up and say, hey, I put a new GFI receptacle and it doesn't work. Can you come take a look at it? Yeah, go take a look at it. And you're going to find out that they put the line on the load or they swapped the hot and neutral. And that's why the GFCI, brand new GFCI, will not even energize. They are fail safe, and that's what we want. So if you swap the line and load or if you swap the polarity, they will not energize. There's two different colored screws on the sides of the receptacle. I'll talk about this in an upcoming session. But the ungrounded hot terminal right here is a brass color, all right? The grounded neutral side on the other side is a light silver color. And the correct way to connect these GFI receptacles is to connect the black wire to the brass colored screw and the white insulated wire to the light colored screw. So saying black to brass and white to light is something I've used all through my career and anybody I've had to teach. Black to brass and white to light is an easy way to remember what color insulation goes where. So replacing a receptacle is covered in the NEC section 406.4D. Check it out, highlight it, 406.4D. The NEC is rarely retroactive, okay? They don't make up a rule and then make you expect you to go and fix the wiring on every house in America. It doesn't happen that way. So, therefore, that NEC section 406.4 parens D parens 3 states that if the receptacle being replaced it is in an area that requires GFCI protection in the current code book, then you must provide GFCI protection for the replacement. In the older cities, in San Diego and San Francisco and Kansas City and Boston and New York and Philadelphia, there's plenty of old homes that still have no GFI protection at the kitchen counter. So if you go in to replace a receptacle for the homeowner, then it would have to be a GFCI protected type circuit before you walk out of that place. So you can do that, like I said, covering it with the GFCI receptacle or a GFCI circuit breaker. It doesn't matter which one. Lastly, also big time, you have to comply with section 422.5, the appliances section of the National Electrical Code, 422.5. So that section requires that crawl space lighting not exceed 120 volts. Dwelling unit outdoor outlets also 150 volts to ground or less, 50 amps or less. This will mean that a direct wired HVAC heat pump split unit has to be GFCI protected. And the same thing with electric vehicle charging units, okay, once the 2020 is adopted. Every vending machine in the United States is required to be GFI protected since 2005. Check out that 422.5 section, like I said. In the NEC section 422.5, also, car vacuum machines have to be GFCI protected for the general public. Drinking water coolers. Every school, every drinking fountain in every school, every office building that you go into has to be on GFCI protection. And the GFCI protected device has to be readily accessible, which most times means you're going to put in a circuit breaker. Spray washers, tire inflation machines, vending machines, which I just mentioned, sump pumps, and dishwashers, both residential and commercial. All these things are listed in that section 422.5. So to wrap up, pick up a copy of the NEC, pay attention to the GFCI subject in the index, especially the 210.8 and the 422.5. There's plenty of other places that need GFI protection, swimming pools and all that, but I'll be covering that when I cover the swimming pool subject itself in upcoming sessions. So that's it for this week. Hope you learned something, and that's the end. Van Wert out.